Hi everyone, welcome to this Connect session, how to create your offline first application in less than 15 minutes without coding. My name is Jose Molina, soy a new solution architect here at Coachbase. Well, during today's session, I will introduce you why offline first applications are so required and demanded nowadays. So what kind of challenges do they have and how Coachbase can help you to dealing with those challenges. So also I prepare a small demo, a small POC, showing you how to easily deploy an end-to-end solution just using Coachbase tools without the needs of developing any type of coding and solution. So by the end of this presentation, we will see some production best practices and tips that you should bear in mind when you go to production with this type of solution. So let's start saying why offline first applications are so demanded nowadays. So if we live in a world that everyone is connected at any time, in everywhere, why do we need an offline first application? Well, so it's true that nowadays you can have instant messages. You can just do online shopping at 12 of the night in the middle of a parking spot. That's perfectly fine. But there are some applications that really have strong requirements. For example, latency. There are some applications like autonomous cars that they cannot be waiting the response from a central server. So the latency of the network will be really high. So the same way, there are other type of applications that will have a strong requirement around the network that will force you to adopting this type of solution. So for example, if you are in the middle of the ocean, you don't have connectivity, or the cost of that connectivity will be really, really high. So there are some options. Also, there are some offline applications, legacy applications that you want to connect to a remote server. So this type of solution will imply that you think about how to solving those challenges just using this offline first approach. Well, offline first approach is not for free. I mean, it has also some challenges. Let's think about that. Let's figure out that you are in the middle of a meeting, and your team is asking you to design this type of solution. Well, it's usually you can underestimate the complexity of this type of solution, and you can simplify the offline first application is just to have an embedded database on my device, and from time to time just synchronize my data to a remote data server, a cluster. Well, there are some challenges that you should be aware of. So the first thing that we need to do when we are working with an offline first application is you need to choose your embedded database. So there are many providers nowadays, and you can choose any of them, and will be a good solution for you, probably. That's no doubt there. So the difficult part comes when you try to synchronize your embedded database with a remote cluster. This remote cluster could be, and probably will be, a different provider. So you will need to integrate somehow the synchronization between them. So you need to create and define and design a process that will take care of the real-time synchronization. And probably another process will need to take care of the authentication. And another process probably will need to choose if you are synchronizing between those two components in a continuous way. For example, you are subscribing to every single change that happens in that system, and in real time you are receiving that change, or in a batch process. For example, during the night, you will synchronize that data in one time. So we start to see how the complexities start to grow. And now, if your use case requires, for many different reasons, for example, legacy, or some legal requirements, or anything, business project and business, you will need to filter in some of the data. So you don't gonna need to synchronize your whole database across the network. So you will just reduce the number of documents that you are synchronizing. So you will need to create a process that will take care of that filtering. Imagine that as also you have multiple users, and each of the users has different profiles, different roles, and you will need to synchronize data, specific data for those users. So, and those users don't want to share that data across the multiple users. So you need to also have a fine-grained access control of that data. So we are keep increasing the number of processes and number of tasks that we need to take care. The same way, so if we are planning to use some sort of a WebSocket or queue system or some sort of a third-party platform, so you will need to keep growing the number of channels and the number of partitions or number of queues that you are using. And probably you will define an incoming and an outgoing channeling for your data. So we can see that the complexity starts to grow, and we haven't dealt yet with the conflict resolution. So this is one of the most important topics that you will have, and challenge that you will have when you are dealing with an offline first application. So if you have users that are sharing data and they can modify it, you could be facing this issue in this example. So imagine that the user A is creating a new document, and that new document is populated to the central server. The central server will synchronize to the rest of the user. This is the happy path. But if two of the user A and C becomes in a offline state, and the user B just create a mutation of that document, just create a new document, a new version of that document, and synchronize with the central server will need to wait to replicate that changes to the rest of the users that are offline. But what happens if those users, at the same time, they are modifying and creating their own version of that document? So when they come back on an online status, they will find out that that document contains some conflicts. So they need to resolve those conflicts in order to don't lose those changes. So we even not started to talk about your business logic. So this is only just operational stuff for synchronizing data and integrating that solution in your system. So if you choose to develop and design and integrate this solution by yourself, good luck. It's possible to do it, but you will spend a lot of time just maintaining this system. And it's not creating the system, you need to maintain this system along the time. So don't worry, because Couchbase has a solution end-to-end, fully integrated offline first application using the same technology and platform. Let's start with Couchbase Lite. Couchbase Lite is an embedded database that you can use for storing JSON documents in your local device. Has the same query language as you can find in Couchbase cluster server. So it will make your assimilation really fast, and your ramp-up knowledge here will grow exponentially, because if you have some experience with Couchbase, it will be really easy for you just working with Couchbase Lite. So the same way, you can make also full text search queries. You can do live queries. You can do queries over arrays, predictive queries. You can choose your favorite language, programming language. That's fine. So in my case, I just choose, I wanted to show you how easy it is to develop a new embedded database inside of my device using Couchbase Lite. Programming in Java is just 2 lines. So the configuration database and just a new entity of the database. And I can configure the path where this database will be located. And also if this database is encrypted or not. So you can create as many databases, embedded databases, as you want. So it's just replicating the database and change the names and the path. So the same way, you can synchronize with a remote server, Couchbase server. But in general, it's not only for Couchbase. if you have a cluster server, a remote server, it's not a good idea to expose your database to external network users. It's you are exposing your business logic, you are exposing the data, the core of your business, to the rest of the world. So for that, in Couchbase, we have a special component, which we call it Sync Gateway, which will take care of all the synchronization process and all the authorization, authentication, and the way that you synchronize the data between these two components. So this will allow you that you will only expose this special component, and your database data will be always safe in your internal network. So in this component, you can define a specific, a special function that will be applied to every single document that you will write into the server. So this function can be used for verifying the ownership of the document, verify the access privileges that you have, verify the structure of the documents. So it's quite useful document functionality that you can take advantage of. So coming back to our sample, how to connect our NVIDIA database to a remote Sync Gateway. Well, it's so easy as declaring a replicator entity. And that replicator, we can configure it. We can make a configuration just pointing to the DNS where we are publishing our Sync Gateway address. Of course, you can define, you can configure this replicator in order to just make it for reading only. So we can read all the information coming from the central server. Just in one single line, we can define pool replication. Or we can define that our replication will be just for writing. So we will push all our information from our local device to a remote one. Or we can define a bidirectional replication. The same way, we can just configure it if we wanted to be listening all the changes that happens and replicating all the changes that happen at the moment that they occur, or just doing a one-shot replication. Of course, Sync Gateway allows you to define users, and those users will have some privilege to access specific channels, a specific subset of documents. So we can use the authentication in order to identify who is connecting to a remote cluster. And if you have a conflict and you want to resolve it in a custom way, because Couchbase already provides a standard way of resolving conflicts, you can define your own custom function and pass through the replicator. Same way, so every single user in the Sync Gateway will have multiple channels associated to that user. So you can specify in the replication only replicate for a specific channel. So you could have multiple replication for different channels in one single database. As you can see, if Couchbase takes care of your synchronization, your life is way more easy, and you can focus on the implementation of the business application requires. So, and the most important point from my point of view is you don't have to maintain this solution. So you have a whole team just taking care of releasing new version of this product, evolving and offering you more functionality. So let me show you a quick demo how you could take advantage of Couchbase and how to create a really fast implementation of a POC without coding. So sometimes happens that just if you are new in the technology, all the operational stuff, all the tasks that you have to do, it will take some time, especially if you have to set up an environment, a new environment. So in order to reduce that time and simplify and standardize those deployments, we in Couchbase, we have a special component that we call it Couchbase Autonomous Operator that will allow you to deploy as a cluster of Couchbase and Sync Gateway just using Kubernetes, over Kubernetes. On top of that, if you want to have even more simplified deployments, you can use Helm chart. Helm will help us to having a simplified using a template of default values for deploying this Kubernetes cluster. And the last, imagine that you don't have any provider, any cloud provider, and you want just to do it a quick demo, or just want to do a continuous integration on your laptop. You want to debug some of the action. Like in this case, you want to do a fast POC. Well, you can use Kind. Kind is a Kubernetes cluster, but using Docker in your local laptop. So it's a quite useful tool that you can reuse for creating your Kubernetes cluster. And for me, this tool is the most important one because it's a generic client that that has a generic implementation of our Couchbase Lite database that will allow you to have a list of commands that you can run on top of that in order to inspect or to browse the data that you have created on your database, on your local database. And you can synchronize, you can use this generic client to synchronize with the central server. So this way, you can verify that the synchronization, the replication is working as you are expecting. So previous to this presentation, what I did, it was just I create my own environment on my laptop. So what I did was just I ran this command with Kind. I just create a cluster, name it demo, with 3 workers, which just generated the structure of a Kubernetes cluster on my local database, on my local laptop. Sorry. Okay. So after that, I just ran a health chance command where in one single line, I just deployed a whole Couchbase cluster with 3 pods on it. And each pod will contain the data, query, and index service, and one sync gateway. The Couchbase cluster will have the default bucket, and the sync gateway will connect to that default bucket with a default user, and the name of the database that we will expose, we'll call it DB. And the last step that I ran prior to this demo, it was just accessing to, was a command of port forwarding for accessing to those pods and make it accessible from my local network. So from our local host, now we can see our cluster that we have deployed on the Kubernetes cluster and the sync gateway. So after that, I will show you in this demo how to connect our Couchbase Lite client into this remote server. So this way, we will synchronize the catalog of data that you will have in this remote server. And also, you can push every single change that you create on your local device or terminal, in this case, CB Lite. We will see how can we synchronize. So let's start with the demo. So we can see that we have the 3 worker nodes or the 3 nodes for Couchbase with the 3 services and the default buckets with a list of documents that is metadata created by the sync gateway, but no documents on top of them. So what I did was just create a small list of documents and load it as a CSV, a JSON list. I use this command for importing them into Couchbase. And we can verify that those documents has been imported also by the sync gateway. If we go and check the metadata, we can see that the channels have been, the metadata contains some mobile attributes. Well, now I would like to verify if this server, this sync gateway, contains and is able to synchronize. So what we can do is go to our browser and using a WebSocket client, we can connect to the changes of the sync gateway. So we can subscribe to every single change that happened in our backend remote cluster. So now we are connecting to our sync gateway, Every time that a new document is created on the backend part, we will be notified via WebSocket. So let's create a new document on the server on the backend part, and we see that as soon as this new document has been created, we receive the notification on the WebSocket client. So this tool, this WebSocket client, it's a useful tool just when we want to verify the server part, so the backend, because we can verify if the synchronization is happening. So now what we can do is, okay, now that we know that the synchronization is working fine, so let's go and create an empty database using SciVLite. We can create an empty database, or we can load an existing database. So we see that we don't have any documents. So let's go and create a new document. Just using the put command, we can create a new document. And now that we have one document in the database, let's go and synchronize that document with the remote database, with the remote sync gateway. In this case, it's not remote, it's local. But we can also specify bidirectional. So there is an option which is a bidirectional, and we can read and write. So we will write into the server the document that we just created, and we will receive also the documents that we imported on the server side. So we can see that easily we can reproduce the behavior that your offline first application will have. So we can do a fast POC with your data. But if you are like me, or you want to create a nice UI, you still don't have to develop your own SciVLite implementation. So what you can do is just use the serve command, and that will expose a list of a REST endpoint that you can use for doing the same operations that you can do via command line. So you can create, you can list, you can do everything. And just reusing that, you can just create a nice UI and call those methods just to show the data that you have. So if you are planning to do a POC, a fast POC, you just using this command line tool, it will help you to do a really fast POC. Well, so once that we complete the phase of the POCs and pilot, we need to think about how our application will look in production. So we need to think about the different best practices that CodeJuice has. So I highly recommend to go to our documentation and read about them. So, but there are many different topics that I would like to talk about about this about production. But for time constraint, I will just focus on a few of them. And let me highlight that, for example, it's important to don't have any single point of failure from the point of view of the operational. Let's say that the main point here is to reduce the network transfer, so defining the channels, or using advanced functionality like Delta Sync will help you with that. Conflict resolution is quite important. Take a look also on the advanced functionality that CodeJuice Lite offers. But one of my first advice when you start with your mobile offline first application is design your actors and entity and the relationship between them, because that relationship can define also the way that the data will be synchronized. Because if you have one store that belongs to one specific country and region, probably you will have data that only belongs to that specific region and that specific store. So that means that you will create a channel with that store name or ID and that country ID and that region ID. So this is just an example of how the data, but it's important to establish the ownership of the data. The same way, you need to think about the first time that your user will synchronize data. So when we define channels, we can segregate data or partitioning data based on the different dimensions. So there are some natural dimensions like time or locations that we can use in order to partitioning the data. So that way, for example, if we wanted to start a replication, just asking all the tasks for one specific user, you can define, instead of just retrieving all the tasks, all the documents, what you can do is just define a channel that will contain all the tasks that happened in 2021. Or instead of that, you could have a replication that will ask all the pending tasks that are pending for this current month. So as you can imagine, the user experience will be improved a lot if your synchronization time, it takes just a few seconds rather than just waiting for minutes, synchronize all the list of documents. So it's really important to do this analysis. And you can always later, with a different replicator, just load the rest of the historical data into your system. But the user experience the first time that they start to synchronize is quite important. And of course, having a production environment means also that you have a monitoring system. Couchbase provides, Couchbase Server and Couchbase Sync Gateway provides Prometheus metrics. And those Prometheus metrics can be shown in a nice dashboard using Grafana, for example. Wrapping up. So offline first application has a lot of potential new business opportunity for any type of industry. But there is already some industries that they already are working with them, because the only option that they have is working with this type of solution, offline first, because they don't have connectivity, because they have to take a decision really fast. So it's important that you know that Couchbase offers you an end-to-end solution that will increase the time to market. They will reduce the time to market, for going to production. And it will allow you to do a different configuration. And also, even if your solution evolves along the time, Couchbase has the different option, and it will maintain it by the Couchbase team. And the most important one is that we as a team, we will help you during this journey. You will be alone. We will be just training you. We will just supporting you and assisting you for success in this project. That's for me is the best value that you can get for us. And of course, summarizing the session is if you have an application and your business depends on the service that you provide, if you don't have internet, you could lose a lot of potential customer, or you could lose a lot of potential earnings. So having Couchbase offline first application, you don't have any problem with that. We will reduce drastically the time to market just using one single provider of this solution, as Couchbase is, with a large experience working with this type of projects. With a scalable solution, it's super easy to operate, and also plus that we offer advanced functionality, like for example, analytics. You can analyze how your customers are using this solution, how the group of, for example, regions are behaving. So you can create dashboard on top of that, or you can use eventing. You have advanced functionality that Couchbase Server Cluster also can provide into this solution. And my contact is jose.molina at couchbase.com. Thank you very much for attending to this session. If you are interested in this topic, there are a few other sessions in Disconnect that they will extend the information that talking about the not only offline first, also computing edge solutions in Couchbase. Thank you very much for attending to this session.